This question asks us to consider the same reaction conditions for the same substrate and decide which pathway, SN2 or E2, will be more favorable at elevated temperatures. Favorability is a delta G term. Delta G, so we need our equation for delta G. Delta G is equal to delta H minus T delta S. Delta H is enthalpy, sum of bonds formed and bonds broken. Delta S is entropy. A way of looking at entropy is the number of molecules on either side of the arrow. Temperature is in the T delta S term. The reaction that has the larger delta S, the larger change in entropy, will be more negative. At elevated temperatures, this term will be more negative, which will make delta G more negative, which will make the reaction more favorable. So at elevated temperatures, the reaction pathway with the larger delta S will be the more favorable reaction, at least at elevated temperatures. If we look at the SN2 pathway, the SN2 pathway starts with 2 molecules on the reagent side, the substrate and the sodium cyanide, and ends with 2 molecules on the product side, the nitrile and sodium bromide. So this reaction starts and ends with 2 molecules. The delta S term for the SN2 pathway is approximately 0. For the E2 pathway, we start with 2 molecules on the reagent side, the substrate and the sodium cyanide, and we end with 3 molecules on the product side, the product, the sodium bromide, and HCN. There are more molecules on the product side. So for the E2 reaction, then we have a positive delta S term. Because delta S is positive for the E2, at elevated temperatures, this term will be more negative, which will make delta G more negative, which means the E2 pathway will be more favorable at elevated temperatures.